In this video, we will investigate implicit differentiation. In order to do so, we will look at a common example. Something that is frequently encountered in calculus is to differentiate or find dy dx for some given expression. The problem here is that no matter how hard we try, we are not going to be able to solve for the y explicitly as a function of x, which means we will require implicit differentiation. So in order to do so, let's just differentiate both sides with respect to x. So we'd have the derivative of x cubed plus y squared is equal to the derivative with respect to x of cosine y. Now on the left-hand side, we have a derivative of a sum, which we know we can write as a sum of derivatives. So let's make this the derivative of x cubed plus the derivative with respect to x here of y squared, and this is all still equal to the derivative with respect to x of cosine y. So let's just work our way from the left to right. When we differentiate x cubed with respect to x, this is an explicit derivative. So using the power rule, this becomes 3x squared. Now when we encounter this next derivative, note it's a derivative of y squared, but with respect to x. This is an implicit derivative because those variables do not agree. We are really thinking here that y is a function of x. So if we want to differentiate with respect to x a function of y, where our function of y here might be y squared or cosine y, we really need to use a chain rule. You have the outside function f, and you have this inside function y, where that inside function depends upon x. So by the chain rule, we differentiate the outside function, evaluate it at the inside, and then we multiply by the derivative of the inside function. So in words, the rule of thumb here is we differentiate that f of y exactly as we would like to, f prime y, and then by the chain rule, we multiply by dy dx. So back to the problem at hand. The derivative of y squared with respect to x. We differentiate that y squared exactly as we would like to 2y, and then by the chain rule, we multiply by dy dx. On the right-hand side here, we also have an implicit derivative. Differentiate that cosine y as you'd like to, minus sine y, and then multiply by dy dx, which comes from the chain rule. Now think about what it is we would like to find. Dy dx. We have two terms involving it, so let's group those together on the left. So if we have the dy dx, there are 2y of them on the left to begin with, and we are adding over sine y more of them. And then we'll subtract 3x squared for both sides. And now divide out. So dy dx, the quantity we are looking for, is minus 3x squared divided by 2y plus sine y. And we've used implicit differentiation to find dy dx. Now, from a procedural standpoint, we see that this can be done in two steps. Essentially, what one needs to do here is step one, you differentiate both sides with respect to x. And then as a second step, we algebraically solve for dy dx.